Okay, Honors Chem, we're going to review real quick how to read the periodic table of the elements and how to tell how many protons, neutrons, and electrons we have in a particular element. So I'm going to start with, let's pick one that's a little different than the examples that are in the other material I gave you. So I'm going to go down and I'm going to find, let's just pick barium. I'm going to find barium on the periodic table of the elements, and I'm going to see that it says 56 on the top. That 56 tells us the number of protons. And then it says 137.3 underneath it. So the information that I get so far is that this 56 is the identity of barium. Barium always has 56 protons. If it doesn't have 56 protons, it's not barium. So if somebody tells you, oh, I got some barium, but it only has 54 protons, you would say, no, you do not have barium, you have xenon. So this is the number of protons. Now, if it's a neutral atom, remember atoms are neutral, meaning that they have the same number of pluses as they do minuses. So the number of protons is 56. The number of protons is how many plus charges we have. In chemistry class, protons are always pluses. If it's an atom, that means it's electrically neutral. That means that it has the same number of pluses and minuses. Minuses in chemistry class are electrons. So if it's an atom, it has the same number of electrons as it does protons. So we have 56 protons, so we have 56 electrons. Plus 56 minus 56 gives you 0. That's an atom. So he has no charge. Usually when we have no charge, we don't put the 0 up here, but you might see it occasionally. So now we know how many protons we have and how many electrons we have. Let's talk about that molar mass, which can be confusing. So this is the molar mass, meaning that if I have a huge sample of barium atoms or 1 mole of barium atoms, it will have a mass of 137.3 grams per mole. Now, we know that most of the mass comes from protons and neutrons. Protons have a mass of 1 AMU. Neutrons have a mass of 1 AMU. Electrons are so small that we do not consider their mass. What that means is there's no way that you could have 0.3 of a proton or a neutron. So how could you have 0.3 grams? Well, that's because each barium atom either has a mass of 137 AMUs or 138 AMUs. None of them have a mass of 137.3. So when you take a huge sample of them, it's going to have a mixture of atoms that have a mass of 137 and atoms that have a mass of 138. We actually have more 137 because the mass is closer to 137. So when you take a big mixture of stuff, you're going to have probably like a 70-30 split. So the example I always use is if today is half the kids in class, it's your 14th birthday, and half the kids in class, it's your 15th birthday, that means half of you are exactly 14, half of you are exactly 15. So the average age in the class is 14.5, even though nobody in class is 14 and a half years old. It's kind of the similar circumstance. Another example of that is to try to just understand what these isotopes mean is, for example, they say that in the United States of America, people have average of 2.3 children. You know that nobody can actually have 2.3 children. You know that people either have 0 children, 1 children, 2 children, 3 children, 4 children, 5 children, so on and so forth. But if you take the average of all of those numbers of kids that couples have, it ends up being 2.3, even though it's not possible to have 2.3 children. So the same thing happens with the periodic table of the elements. It is not possible to have one atom that has a mass of 137.3. But when you have lots and lots and lots of atoms, which is called a mole, it has an average mass of 137.3. So you have to know whether you have an isotope of 137 barium or an isotope of barium 138. You'll be told that. So let's just take our most common isotope of barium is 137, barium 137. So that means that particular atom and all the atoms like him are going to have a mass of 137 AMU. This mass of 137 AMUs is the number of protons plus the number of neutrons. So we know this barium, in order to be barium, every barium has 56 protons. Remember, electrons are so small that we don't consider their mass. The reason for that is, and if you think about when you go to the doctor and the doctor says, step on the scale, I want to get your mass, you usually take off your shoes, you would take off a big heavy coat, you would set your purse down or any bags you're carrying, but you wouldn't really worry about taking off your earrings or taking off a necklace. Some people even take off their belt. The reason you don't worry about taking off your earrings or necklace or something like that is because they're so small, it's not really going to change your weight enough to be considered. And that's why we don't consider electrons. So in order to find the number of neutrons in barium, we would rearrange this equation, and the number of neutrons would be the atomic mass number minus the number of protons, and that will tell us the number of neutrons that barium has. So I don't care if you use a calculator. 137 minus 56 tells us that this particular atom has 81 neutrons. So just based on what we learned about the periodic table of the elements, you now know that barium has 56 positive proton charges, 56 negative electron charges, and 81 neutron charges. Its average atomic mass is that number right off the periodic table of the elements. It's 137.3. The mass number, so the atomic mass number is what it's called, is the number of protons plus the number of neutrons. That's going to be your round number with no decimals, is 137. The atomic number, which is the identity, is the number of protons, or 56. So that's all the information. I will come back to barium and I will tell you what this means for isotopes and what this means for ions at a later date.